In this video, we're going to look at how to generate and pull information from enzyme kinetics graphs. We're going to start with Michaelis-Menten plots. Michaelis-Menten plots represent measurements taken of enzyme activity in a set of experiments in which you vary the substrate concentration, but keep a single enzyme concentration for each of these. So, the typical result of the experiment is that as substrate concentration increases, enzyme activity increases. And then there's a curvy part. And then another straight line relationship in which as substrate increases, enzyme activity fails to increase. That's drawn badly. Let me try again. So you get this curvy part, and then you get another straight line relationship where enzyme activity is not increasing. So as substrate levels rise, enzyme activity rises at the lower values of substrate concentration, but then reaches a plateau. And at that plateau, any increase in substrate concentration has no effect on enzyme rate. So, what are the units we're talking about here? So, I said that we're measuring the rate of enzyme activity. Now, a rate of enzyme activity is going to be measured by how much product is made. And not just how much is made, so here's a quantity of product, micrograms, say. It's supposed to be micrograms. But per unit time, so micrograms per minute. This is our dependent variable. Micrograms per minute of product is a typical value. It could be milligrams per second. It could be any value that represents some quantity per unit time of product made. The x-axis is always the independent variable. That's the thing we're changing and measuring the results that come from those changes. So here's our substrate concentration. What units is that going to be in? Well, you can also have a quantity of substrate that's going to be something like the quantity of product maybe. But this is the quantity per unit volume, right? So perhaps milliliter. How many micrograms of substrate there are per milliliter of fluid in the test tube. Another way of representing concentration might be a percent solution. When you use starch as your substrate, you have to use percent starch. Another way you can measure or you can denote how much substrate you have is the molarity. So millimolar is a typical, or maybe that's millimolal, is a typical concentration measurement. Okay, so dependent variable is a rate, micrograms per minute of product is an example. The independent variable in a Michaelis-Menten plot is always substrate concentration. Milligrams or micrograms per mil is an example of a concentration unit. A Michaelis-Menten plot provides these two straight lines, but not all proteins have Michaelis-Menten kinetics. If there is no early straight line relationship between reaction rate and substrate concentration, then Michaelis-Menten kinetics are not present, and you wouldn't call it a Michaelis-Menten plot. We're going to look at other relationships between substrate concentration and reaction rate later in the term. But this is the most typical result you're going to get, and these are Michaelis-Menten kinetics. So why is there a straight line relationship between reaction rate and substrate concentration? And the answer seems to be that substrate is what is limiting reaction rate when substrate concentrations are low. And that means the enzyme is finding and binding substrate, getting it into its active site so it can turn substrate into product. And the more substrate that's around, the faster it can find it, the faster it can get it in its active site, the faster it can turn it into product. And what's limiting the rate of the reaction is its ability to get that substrate into the active site. And we can see that that's true because when you increase the amount of substrate, the enzyme reaction is faster. What about when that is no longer the relationship? What about when substrate concentration increases no longer lead to reaction rate increases? What that represents is when there's so much substrate present that as fast as the enzyme can turn substrate into product, that's how fast the substrate will be replaced in the active site. So what's limiting the reaction up in this flattened part, this plateau part of the curve, what's represented is how fast the enzyme can conduct the catalysis, can generate product from substrate, not limited by substrate concentration, because substrate's available in such excess that the product is being made as fast as is possible, as fast as the chemistry is possible. When Michaelis and Menton recognized the fact that there are these two straight line relationships in typical kinetics, they recognized too that they could describe the results of these experiments, well, first off as drawing graphs, but as just two numbers. Two numbers tell you all you have to know about the kinetics of an enzyme with respect to substrate concentration.